So today's objective is to learn about the circulatory, respiratory, digestive, urinary, and lymphatic or immune system. And that's my goal, to get through all those. If we can get through all of them, that'd be awesome, but we'll see. So our essential question for our first one, which should be on page 113. So the circulatory system should be on page 113. Remember that the essential question should be at the top, and the essential question is, why is the circulatory system important to the body, and what can happen if the system fails? So that's where we're at now. So, looking at the circulatory system, the major function of the circulatory system is to transport blood, which the blood basically carries oxygen and nutrients, which are the good things, and carbon dioxide and waste, which are the bad things, to and from body cells. So basically, the circulatory system is a transport system. It basically transports, it moves different things that are needed or not needed inside the body. Looking at the organs, we can see that the major organ obviously is the heart, and then you have arteries and veins. All three of those are major. All of them are needed in order for that transport to occur. Now, if we think of the circulatory system, if you look, this is the only one I told you that you probably want to have in two colors, because where there are arteries, there are veins. Due to the fact that the arteries are the ones that are going to be taking the good stuff, and the veins are the ones that are going to be taking the bad stuff away. So, if you didn't do it in two different colors, you're going to have to find a way to make sure that you can distinguish that there are two types of vessels in all the areas. So looking at specifically what the organs do, we can see that, and we probably know that the heart is a muscle that pumps blood through the body. So the heart is a muscle because it's made out of cardiac muscle. So hopefully, as we're doing these notes, you start realizing that all these systems are working together in one way or another. They don't work by themselves. There's no way. So the heart, which is the muscle, basically pumps blood through the body all the time. Okay, from the minute you were basically almost conceived and the heart was formed, it has been beating until the minute that you die. Alright? It continually works 24/7 to make sure that you get blood throughout your body, because without that blood throughout your body, your cells don't get oxygen, your cells don't get nutrients. Your cells don't get rid of carbon dioxide, which is a poison to your body, and get rid of waste. The other two organs are the arteries and the veins. If you look at the arteries are the ones that carry blood from the heart to the cells. So any blood that is going from the heart to the cells is going through an artery. And for the most part, that blood has oxygen and nutrients. There's one exception, which is the pulmonary artery, which is the artery that takes the blood from the heart to the lungs. That's taking waste. But for the most part, all arteries, except for the pulmonary artery, is taking oxygen and nutrients. Same thing with veins. For the most part, all veins are carrying blood that has carbon dioxide and waste. So veins are the vessels that are carrying blood to the heart. So away from the heart are arteries, to the heart are veins. Now, obviously, without this system, your body would not be able to work, just because at any moment in time, if blood stops going to a certain part of your body, that body or that part is going to die. That's what a stroke is. A stroke is whenever one of the little vessels that are going to your brain gets clogged, no oxygen is getting to the brain, you get a stroke. A heart attack, for the most part, is because even though the heart's a muscle, you're thinking, oh, it's pumping blood. It also has veins that go to the heart that provide blood and oxygen and nutrients to the heart muscle. Well, whenever those little arteries are clogged, that part of the muscle isn't getting any oxygen, they get a heart attack. So the only way around those things is actually to go in and either unobstruct the artery, but a lot of times those are very, very small. So what ends up happening is they do what they call bypasses, which means that they basically cut that artery and then they join it to another one and they bypass the section that was clogged. Okay? But obviously that goes in and they have to go through heart surgery, which I actually have seen twice, like live heart surgery. And it is. And then they go in, they cut them up, they stop the heart. Now when they stop the heart, they obviously connect it to a machine, and the machine's like, I guess, circulating their blood for them. Then they go in, they cut, like the one I saw, they actually took a vein from their leg, and then they took that piece of vein and put it into their heart to do that bypass. Okay? So there's ways to fix things as long as it's not too bad. Okay? Questions? Yes?
How would they clog?
How what?
How would they like the vein?
How do they get clogged? Cholesterol. Truthfully. Cholesterol and fat. Obviously, the higher the cholesterol diet, the more fat you have in your blood. That blood is going through a vessel. Sometimes those vessels are really, really, really skinny and very tiny to a point that only one red blood cell can go through it at a time. Well, so if it's so skinny and you have all that fat starts basically making like a layer inside. It's called plaque. And then as that layer gets thicker and thicker, eventually those blood vessels can't go through it anymore. That's how the clogging occurs. And it's usually fat and cholesterol. Question was it?
How do you connect the arteries?
They sew them together. Yeah. Yes?
Why would you say like the blood is blue?
They say that because the reason blood is bright red is because it has oxygen. Okay? So if you see that the arteries are red, well, what are the arteries carrying? Oxygen, right? The veins are blue because they're not carrying oxygen anymore, they're carrying carbon dioxide. So, basically, the color of our blood turns bright, bright red when it has oxygen. When it doesn't have oxygen, it kind of turns like a purple, not a blue, but like a deep maroon, like a purplish color. That's why whenever you look at your veins, they actually look bluish. The reason for it is because the blood that's going through there are not carrying any oxygen. So if you look, and you look at your arms and things, you don't see red. You see those bluish, right? Because think about it. Isn't what's important to you oxygen? Right? So if what's important to you is oxygen, don't you think the arteries are going to be much more hidden in case you cut yourself? You don't want to cut an artery. If you're going to cut anything, it's probably better to cut a vein than an artery, right? You don't want to cut anything whatsoever. But your veins are actually deeper inside your body, more centrally inside your body, because they want to be protected, because they're the ones that are carrying the oxygen. Your veins are the ones that are closer out to your body. And that's why whenever you see them, they look kind of purplish, because they're the ones that are not carrying oxygen, they're carrying carbon dioxide. Okay? Yes?
Why do people say whenever you cut like right here, you die or something like that?
Well, like if you ever see movies, they usually show that you're cutting this way. I'm not giving you ideas. But, usually, because you have a lot of veins right here, if you cut deep enough, you're basically going to, obviously if they do that, they're not going to go to the doctor and say, oh look. Yeah, they're doing it because they're trying to commit suicide. So they do that and then they let themselves bleed out. Now, if you ever notice, like they're usually in the bathroom and they're in water, what they do is they try to make it to where it doesn't coagulate, meaning it doesn't dry up. So if it doesn't dry up, you're going to bleed out. The deeper you cut, the less likely it is to close up. Because anytime you get a cut, almost immediately it starts drying up, right? The reason for it is because your body's trying to protect you from bleeding out. Well, if you cut deep enough, or you cut like veins that are bigger, those are harder to close up. That's why it's easy to get to them here, because you don't have a lot of tissue in back. So that's why they tend to go here. Question?
Does it cause like spelling and say if you do cook sugar, doesn't it cause like spelling inside your skin and stuff? Like say you cook stuff and you start bleeding, where you know the blood goes, it's
Like internal bleeding? No, you bleed out. Internal bleeding is if something happens, like for example, if you're in a car accident, a lot of times they worry about internal bleeding because you hit yourself so hard that something inside, the vessels inside, break, and your skin doesn't break, so you're bleeding inside. But that's because you have trauma to your body that doesn't make a cut. If it makes a cut, you're going to bleed out. The blood's going to come out, not in. Yes?
Some people, like when you have a bruise.
Yeah, that's basically you burst vessels. So, like for example, if I hit myself right here and I get a bruise tomorrow, what happened is the vessels that are right here, what popped, and they allowed blood to come out. But usually, something like that is usually not too bad, unless it's something like a concussion. A concussion, basically, that's what it is. You burst vessels and there's a little bit of blood there. Any other questions or circulatory system? Okay, so we're gonna move on. But before we move on, I gave you those little sticky notes. Remember what we're doing is we're writing 1 or 2 key words for the function and then the major organs. So truthfully, the best way to set these up is to write key words and then write your 1 or 2 words and then write organs, write the major organs. Okay? So I'm going to give you 2 minutes to get this done. So we're going to move on to the respiratory system now. Same essential question, why is the respiratory system important to the body? And what can happen if the system fails? That should be going on the top of your page 114. Now looking at the respiratory system, the function of the respiratory system is basically to exchange gases. Specifically, oxygen being exchanged going in, meaning inhaling, or carbon dioxide going out, meaning exhaling. Now, the reason we obviously need to do this is because we need oxygen to our cells and we need to get rid of carbon dioxide because it's poisonous to our body. So, the respiratory system does that for us. It exchanges those gases between our blood and the environment. So, whenever your air goes in, yes, it goes into your lungs, but it has to go into that blood in order for that oxygen to be able to get to all your cells. So looking at the major organs on the body, you obviously have your larynx, your trachea, which is basically just going to be a passageway for the air, and your major organs, which are your lungs, and your diaphragm, which is actually a muscle. So once again, we're looking at things that are being related. So even though the respiratory system is a system, it still has to work with the muscular system because without that muscle, that diaphragm, you wouldn't be able to breathe. Okay? That muscle is what allows you to inhale and exhale. Now, those are the major organs, but what we need to realize is that the air is exchanged with the blood, and it does that in smaller areas in the lung, which are called alveoli. An alveolus is basically a little air sac. So it's a little sac, the air is in there, and it's surrounded by these arteries and these veins. So when you breathe in, the oxygen that is here goes into the artery. The carbon dioxide that's in the vein goes into the sac. So when you breathe in, oxygen goes in over here, carbon dioxide gets put in, and then you breathe that out. So always make sure that you realize that the inhaling and exhaling is occurring, but it's occurring with your blood system. Because without the blood, it's not going to go anywhere. Okay? Now, looking at specifically what each one of those things does. So, a couple of the organs for the respiratory system are the larynx and the trachea. That's really just a passageway, the passage where air goes through from your nose to your lungs. The major organs of the respiratory system are the next two, the lungs and the diaphragm. The lungs basically contain that alveoli where oxygen and carbon dioxide are exchanged. So obviously that's important. And what makes those lungs work is the diaphragm, which is the muscle that contracts and relaxes and allows you to inhale and exhale. So basically the lungs is really just a big air sac. It's a sac. It allows air to go in, it allows air to go out, just like a balloon would. Okay? You can put air into the balloon or you can take the air out of the balloon. So think of the lungs like a balloon. Now, the balloon by itself, if I just have it in my hand, is it going to fill up or decrease in size if I just have it in my hand? No, right? Something has to happen. I have to blow into the balloon to get it in there. Well, what ends up happening, or what allows your air to go in or out, is your diaphragm, which is basically that muscle that is right here, right under your rib cage. That muscle contracts and relaxes. So if you really think about it, if you ever kind of put your hand here and kind of feel yourself breathe in, breathe out, you can feel this go down and up. It's going down and up because when it goes down, it allows your lungs to expand, meaning fill up with air. When it pushes up, it pushes on your lungs and pushes all the air out. So think about it. It's actually much harder for you to breathe all your air out than it is to breathe in. I mean, if you really think about it, if you go, like you can feel it right here, right? Because what's actually happening is your diaphragm is trying to push everything out of your lungs. It's easy to breathe in because all you're doing is you're relaxing that muscle, which allows your lung to fill up with air. But when you're breathing out, you're actually pushing it out. Okay? So obviously the respiratory system is important because it gives us what? Oxygen. Can we live without oxygen? No. That's why smoking is so bad. Because what ends up happening whenever you smoke is these lungs, these alveoli, technically these right here, these alveoli, basically, oops, sorry. When you smoke, you're smoking in that smoke, right? Putting that smoke into your lungs. So not only you're putting oxygen, you're putting that smoke in there. That smoke has something called tar or nicotine. That tar is like, think of molasses. It's very gooey and viscous. Alright? So that stuff gets in there and it can't leave because it's not like you're going to breathe that out. It's very viscous. It sticks. It's sticky. So it sticks into that alveolus. Over time, it hardens. It gets hard. So, what ends up happening with all these alveoli, or these lungs, is that now they're covered with this sticky stuff that ends up getting hard, and it hardens the lung. So think about it. If I had something that is hard, is it easy for me to blow it up and make it bigger? Think of like one of those plastic bottles. Okay, you can crush those, right? You can blow into that bottle and make it expand again. But is it easy compared to doing it with a balloon? No. Why? Because the plastic is harder, correct? So think about it. If you're smoking and you're putting all that stuff in and it hardens your lung, is it easy for that lung to fill up and then decrease? No. That's where you end up having emphysema, lung cancer, things like that, is because your lungs really are getting hardened, and truthfully, I've seen a lung that has lung cancer or of a smoker, truthfully, compared to a non-smoker. This non-smoker lung is kind of like pinkish. The smoker's lung is black. No, it's black. Mainly. What color is the smoke that you're breathing?
That was like brown or green.
It's black. It turns black and it's hard. Like, I've touched a lung before and it's squishy. It's like, think of a sponge. I used to, whenever I was in high school, I took anatomy class, anatomy and physiology class, and it was honors class. So we got to go to the hospital when,
So you took people's lungs?
well, not that they were alive, they were specimens in bottles.
Oh, okay. That like,
Yeah.
so
But,
you just like
so basically the lungs are very squishy. Think of like a sponge. A smoker's lung was very, it was like I said, it was completely black and it was hard. Okay? So obviously you want to make sure that you take care of your lungs just as bad that if you don't, are you going to be able to get the oxygen you need? Okay? So any questions on the respiratory system? Yes? Well, yeah, there's basically, a lot of times it's spasms. Because think about it, when you hiccup, you're going this way, right? So it's just spasms.
Now it's not hiccuping, taking the stomach.
Well, because it feels right here. And here's your stomach's right here. Alright, so now we are going to move on to the digestive, but before we go to the digestive, get your sticky note. Remember 1 or 2 key words. And then your major organs. So, we're on to the digestive system. Quiet down, focus. We're down to the digestive system. Basically, the digestive system really just breaks down food and absorbs nutrients. So, that's pretty simple. Everybody should know that. That when you digest, you're breaking down food and you're absorbing nutrients. Now, if you look at the digestive system, it has a lot of organs. The reason it has a lot of organs is because a whole lot of different things need to happen. Now, what I need you to understand is the major organs, which basically the major organs are the stomach, the small intestine, the large intestine. Those are your major organs. But what you need to realize is that all these other things need to occur, or need to happen, or need to work in order for those 3 major organs to do their job. So looking at specifically what each one does. So the esophagus is just basically the passageway of the food, or what the food does or goes through from the mouth to the stomach. So it's just a way to get from the mouth to the stomach. The process of that movement can be called peristalsis, and it's a physical change. So one of the things that you're going to have to make sure that you understand about the digestive system is that not only do you need to understand the parts and what's happening, you also have to add the understanding of what type of change is occurring. So the movement from the mouth to the stomach through a process called peristalsis is a physical change. And how do we distinguish a physical change from a chemical change? Okay, so physical can be broken down to smaller, but in chemical, it changes the components and you get what?
Or a new substance.
A new substance, something completely new. Okay? So, in the esophagus, whenever you're passing the food and the food's going from your mouth to your stomach, yes, the food is being broken into smaller pieces, but it's really still the same thing, for the most part. So overall, we think of that as a physical change. Then in the stomach, you have acids and enzymes that break down the food into completely different chemicals. So you have proteins being made or broken down into amino acids. You have sugars being broken down into carbohydrates. Okay? You have oils being broken down into fat. Okay? So whenever you have that change, that is considered a chemical change. So in your stomach, whenever you have anything such as acids or enzymes, or if you ever see the word acids or enzymes, immediately think chemical. Because what's actually happening is being broken down into something completely different. Then after it's in your stomach, and your stomach, mixes it up, it goes into your small intestine. In your small intestine, they finish breaking down with some enzymes, so that's chemical, and then it gets absorbed through the wall and goes into your circulatory system, into your vessels. That absorption is physical, because all it is taking those chemicals that are in your small intestine, and it passes through the wall into the vessels, and then it gets moved to your different cells. So that part is a physical change. Then whatever's left over goes into your large intestine. In your large intestine, you absorb the remaining nutrients and the extra water. Okay? That's a physical change. And then eventually it's going to go into your colon and excrete it out your anus due to the fact that it ends up being waste. So after you take everything out that you need, you excrete it. Now that's part of the respiratory system, which we'll discuss when we get to that system. But the other things that were in there in our thing were the liver, the gallbladder, and the pancreas, which are all organs or glands that basically secrete enzymes or hormones to help the breakdown of food. Now the secretion or giving off of the hormones is physical, but anytime, once again, that you see the word enzyme, immediately think chemical, because that's what they're looking for. They want you to understand that both enzymes and acids, what they do is they go through a chemical change. Okay. Now, obviously, the digestive system is important due to the fact that without it, would you be able to get the energy that you need? No. You need to make sure that you get as much of it out as possible, and that you're getting good things. Whenever you eat something that is bad, you either throw it up immediately, or you get food poisoning, right? Which ends up in diarrhea and things like that. And the reason for it is because your body's trying to get rid of it. However it can get rid of it, it's going to get rid of it. So anytime you eat something that has too much bacteria or has things that are harmful to your body immediately goes to the point, I need to get it out of my system. Fastest way, be it throwing it up or, once again, diarrhea, because it's just going to go immediately through your body where nothing gets taken out, it's just being flushed out. Okay? But it's your body's protection, so if that happens, obviously without you having other issues and doing it to yourself, but if that happens naturally, it's because you've eaten something that your body knows should not be in your body. Okay? Alright, any questions over the digestive system? Yes?
You know whenever people are like, oh, I'm fat or whatever, with like their stomach, does it like really go to their stomach or to their intestine?
The reason people get fat or gain weight is because, so they eat, right? All that food and stuff gets put into the bloodstream, and then it gets taken where it needs. So if I eat a lot, all those nutrients and stuff is going to go to my bloodstream. My bloodstream is going to take it to the cells. But if all I do is sit around and do nothing, then those cells don't need that energy, right? So what your body does is that, okay, well, it's not needed, it's not being used, so I'm going to store it. So they take it to your fat cells. And that energy is turned into fat, is stored as fat. Because they figure, okay, well, whenever this person needs it, like let's say I'm fat, and then I start working out, so now I need a lot more energy, right? And I'm not eating a lot, so I need a lot more energy. So your body, what it starts doing is it starts taking those fat cells, breaking them down, and using them as energy. So you're not getting fat in your stomach. What's happening is all that excess energy, all that excess nutrients that aren't being used at this moment get stored as fat. So, and people store fat in different areas. Like, for example, I actually just found this out. I was looking at a program, and they say that you know, men that are overweight or like obese are at a higher risk of heart failure and things like that than women. I mean, it's bad both ways, but they're at high risk because of men tend to store their fat around their organs. So the guy's fat tends to be inside around the organs. Well, if it's around the organs, it's going to hurt the organ, right? Women tend to store fat right under their skin. So have you noticed that you can tell that a girl's gaining weight a lot faster than you can tell with the guy? And the reason for it is because the guy's storing their fat around the organs, which is inside, you can't really tell. A woman, immediately, because you're storing it right under your skin. Okay? Which, both of them are bad, but obviously, storing it around your organs is much worse because your organs are vital. Okay? Any other questions?
Show me how that works.
Okay, I can come back to it once you figure it out. Yes?
What's metabolism?
Metabolism is how fast your body burns down calories or breaks down food. The breaking down of food is normal, right? But how fast your body basically uses that energy is your metabolism. Your muscles basically is what uses the energy, right? So the more muscle you have, the higher metabolism you're going to have because the more energy your muscles need. So your muscles have to do, your metabolism has to do with how fast that energy is being used. The faster you use it, the more you burn up, the less you store. So have you ever heard that younger people have a higher metabolism, so they tend to be able to eat more than an adult? Reason for it is because your body just naturally burns calories a lot faster because you're growing and you're doing all these other different things in your body. Your body naturally burns the calories faster than an adult because an adult isn't growing anymore for the most part. And so if that adult isn't exercising and making their body use the energy, then it's going to be stored. Their metabolism is lower. So whenever you exercise, you increase your metabolism because, one, you're making more muscle, and two, you're using more energy faster, which basically that's what metabolism has to do with. Yes?
Like you're saying about the fat, how it's stored on raw organ. Why would it think, like, say if the energy's not being used, why would you store it there instead of just burning it off naturally?
How are you going to burn it off if you're not doing anything? It has to be stored. Your body isn't just going to excrete it because your body never knows when you're going to have your next meal. So your body is going to store it. I mean, that's just how our bodies are. Because in the past, we didn't have as much food available to us as we do now, right? So genetically, our body is ready to store because in the early days, as humans, we didn't have a lot of food available. So you had to store energy. And you store it as fat just because it's the easiest way to store energy in your body.
So you can't get it off, right?
Yeah, once you start exercising and you don't, because, okay, so let's say I exercise and I need about 30,000 calories to be able to survive with the exercise, right? But I only eat 1,500. So the other 1,500 that I need to survive is going to come from my body. So it starts burning that fat away. That's why whenever people go try to lose weight, it's not just you go exercise, it's you go exercise plus you need to watch what you eat. Because if you're exercising but you are eating the same amount of calories needed to exercise, then you're just kind of canceling those out. So you always have to kind of look at those different things.
So you have to have, right? Depending on how much you eat.
Yes. Yes.
So, like, let's say there's, like, you know how people are, like, they're gonna clean the, I don't know, like, the intestines or whatever, so...
They flush their system, yes.
Yeah,
Mhm.
so where does the food stay there? Because, like, some food, like, you know how...
It's just your body, as good as it is never perfect, and also has to do with your diet. Once again, we talked about the fats, right? They're sticky. Okay, they're sticky, they stay. That's why they say to increase your fiber, because fiber doesn't stick. It basically is like this big mush of, think of grass, celery, and celery doesn't get digested, it doesn't get absorbed. So this grass stuff is pushing and pulling everything away. So whenever they do something like a cleanse, what they're doing is they're putting something in their body that will try and flush everything else that kind of gets stuck. I mean, just because our systems are good, but I mean, they're never perfect, especially because our diet is so bad. Okay.
So they're keeping everything we don't need.
Pretty much, yes. When you do a cleanse, yes. Yes.
What does it mean to like get your stomach pumped?
When you have stuff in there that you shouldn't have, like for example, you drank, they do that for people that are like, have alcohol poisoning, they drank too much. You have so much stuff in there that your body needs to get rid of and it's not doing it on its own. So basically what they do is they go in and they're basically making you throw up and taking everything out that shouldn't be there. But it's, for the most part, a session, like a throw-up session. Yeah. Any other questions? Alright, we're not going to have time to go on to the next one, but what you can do is go ahead and do your keywords and your organs. And then if you get that finished, you can very quickly go ahead and draw that one, and we'll do the notes tomorrow, but go ahead and get that drawn out today.